So welcome to all in this next video. Okay, in the last video we have seen the basics of the composite function, and now we are going to see the examples on the composites functions and how they are partially differentiated. Okay, so let's start with the example. So this is our example. If z is equal to f of x y, that is z is a function of x comma y, where x equal to e raised to u cos v and y equal to e raised to u sin v, then prove that y into delta z upon delta u plus x into delta z upon delta v equal to e raised to 2u delta z upon delta y. Okay, so here x and y both are the functions of u comma v. Okay, and z is a function of x comma y, that is z is a composite function of u comma v. Okay, now first we will find delta x upon delta u, that is partial differentiation of x with respect to u, and we will also find delta x upon delta v. Similarly, we will find delta y upon delta u and delta y upon delta v. Okay, so why are we going to find these four terms before? The answer is that for finding delta z upon delta u, we will use the formula delta z. First, delta z is a function of x comma y. So first it will go to x, that is delta z upon delta x into delta x. Delta x is a function of u and v, but we are now differentiating with respect to u, so it will be delta u. So we will need the value of delta x upon delta u. Similarly, continuing this formula, we will get plus of delta z upon delta y and delta y upon delta u. Okay, so we will also need delta y upon delta u. Similarly, we will going to need delta x upon delta v and delta y upon delta v for the formula of delta z upon delta v. Okay, so we will find these terms before. See here, x equal to e raised to u cos v. First, partially differentiating with respect to u, so here v will be constant, so cos v as it is, and differentiation of e raised to u with respect to u is e raised to u as it is. And now partially differentiating with respect to v, so here u will be constant, so e raised to u as it is, and differentiation of cos v is minus sin v, so minus sign here and sin v. Okay, similarly we will differentiate y equal to e raised to u sin v. Okay, partially differentiating with respect to v, so here u is constant, u will be constant, so e raised to u as it is, and differentiation of sin v is cos v. Similarly, partially differentiating with respect to u, so v will be constant, so sin v as it is, and differentiation of e raised to u is e raised to u as it is. Okay, now we will use the formula. Here z tends to x comma y, that is z is a function of x comma y. X comma y is a function of u comma v, therefore z is a composite function of u comma v. So first we will find partially differentiation of z with respect to u. So first, z is a function of x comma y, so z goes to x and z goes to y. Okay, a positive plus sign in between, and z x is a function of u comma v, but we are partially differentiating with respect to u, so delta x upon delta u and delta y upon delta u. Okay, so our formula is delta z upon delta u equal to delta z upon delta x into delta x upon delta u plus delta z upon delta y into delta y upon delta u. Okay, you can find all these formulas explained clearly in the previous video. Go and watch it for the formulas. Okay, so we have find the value of delta x upon delta u, and we have also find the value of delta y upon delta u. So we will put it in the equation. So we get e raised to u cos v delta z upon delta x plus e raised to u sin v delta z upon delta y. Okay, but we can't find the value of delta z upon delta x and delta z upon delta y. Why we cannot find the value? Because it is given that z is a function of x comma y. It is not mentioned what's the function f, means it is sin x वगैरह, the like things. Okay, so we don't know what the function is, so we will keep at as it is. Okay, so now we will partially differentiate z with respect to v. So z is a function of x and z is a function of y, so it goes to delta x and delta y, a plus sign in between, and x goes to delta v and y goes to delta v. So delta z upon delta v equal to delta z upon delta x upon delta v, plus delta z upon delta y upon delta v. Okay, so that is our formula. Again, we know the value of delta x upon delta v and delta y upon delta v, so we will put it in the equation. So we get delta z upon delta y equal to e raised to minus u sin v into delta z upon delta x plus e raised to u cos v delta z upon delta y. Now we will consider the LHS. Okay, considering the LHS, we get y into delta z upon delta u plus x into delta z upon delta v. Okay, so we have written delta z upon delta u and delta z upon delta v. Okay, so but in the given question, from the given question, we know that the value of e raised to u cos v is x and value of e raised to u sin v is y. So using these values, so we will use these values, and using these values we can write that e raised to u cos v, e raised to u cos v is x, e raised to u sin v, e raised to sin v is y, and it is also y minus y it will become, and this will become plus x. Okay, so writing them like this, we get y into x delta z upon delta x plus, if we multiply this with y, if we multiply the inside with y, here will be y, here will be y square, multiplying by x it will be minus xy, and here will be x square. Okay, so see here, plus xy delta z upon delta x and minus xy delta z upon delta x cancelling, and here it becomes x square delta z upon delta y plus y square delta z upon delta y. Okay, so we written them as it is. Okay, and delta z upon delta y we took common, but again we will put the value of x and y. We know x is equal to e raised to u cos v and y equal to e raised to u sin v. Okay, so x square will be e raised to 2u cos square v. We took e raised to 2u in common, and here it will be e raised to 2u sin square v. From both the terms we took e raised to 2u common. Okay, so e raised to 2u cos square v plus sin square v delta z upon delta y. By the golden rules we can write that cos square v plus sin square v equal to 1. So we get e raised to 2u delta z upon delta y. That is our RHS. So that was our first example. Thank you for watching this video, and also subscribe to our channel, hit the bell icon to get the latest notification of our videos. In the next video we are going to solve another example on the composite functions partially differentiation. Okay, have a good day.